Hello, this is Dr. Y.S. Rao. In the previous sessions, we have discussed about embedded C, then about the hardware initialization, specific control words related to input-output devices. We also discussed mathematical models and various programming techniques. Before we go further about the sensors and their programming, let us discuss about the fabrication part. The board, as explained in the initial videos, consists of a CPU, a controller, interfaced with several sensors. So this board has been designed, and if you can see, the final version of the board looks like this, where you have explained earlier two CPUs. One is ESP-32, the outer line. Inside you can also fabricate Raspberry Pico W CPU. So let us mount component by component and then test them. So once, if you remember my earlier videos how to design the PCB, I will show you the link. So if you refer videos, the link, which is RM Reddy's Go Green Technologies Private Limited, there are several videos, particularly the PCB design Eagle Software Part 2. In this video, both the videos, first is about the design principles, then about the software itself. Here I described about how to design the PCB. I strongly recommend at least use one software how to design the PCB, circuit diagram and layout. Refer these videos and design it. Once that is done, assuming you are able to design this, it is only question of converting the layout into PCB form, which is a chemical process, which we generally do it in our fabrication lab. And assuming your PCB is made where logically your circuit is correct, however, there is no guarantee that physically it is made as per your design, because always there is a possibility of manufacturing defects. So let's see, whenever you are given this PCB by the manufacturer, the first and foremost thing one should do is check the continuity. I know it's difficult to check all the tracks. Tracks are there on top side, tracks are there on the bottom side, but at least check the supply track, because if supply track, if there is a problem, either open or short, and once you mount the components, then it's very difficult to find out the manufacturing defects, because the supply tracks are passing through the entire PCB on the top layer as well as the bottom layer. So what is top layer? Top layer, as you can see, top layer means where this silk screen, the name of the components are printed, that is called top layer. And bottom layer, generally this silk screen won't be there. So components are mounted on the top side and soldered from the bottom side. However, SMD components, surface mounted devices, components are soldered on the top side. So what is the difference between SMD components and normal components where the LEDs are there? in SMD components there won't be any holes. If you see the pads doesn't have holes. So the holes are not there, but however the component name is mentioned, it means it is a surface mounted device. It doesn't mean that all the holes are pads. No, these small tiny one which is having hardly less than 10 mils, they are not meant for soldering. They are called plated through holes. Means these tracks, they are moving from top to bottom, bottom to top. Like say for example, if you see a double-sided PCB, let's say the same PCB which right now we are using, if you quickly visualize this, how it looks like, you can see this is how it looks like. This is what exactly we have made. But if you want to see the top layer, then I will switch off the bottom layer. Now you will see the red lines which are there on the top side. It doesn't mean that, right, these lines, these pads are meant for soldering. No, they are plated through holes. The reason is these tracks are switching from top to bottom and bottom to top. Right, as you can see, these plated through holes are meant for switching the track from top to bottom and bottom to top. So these are not meant for soldering. The soldering pads are either these holes or SMD components which are square in size. Okay, so these are the surface mounted devices. Alright, so whatever. First, what I said, let's verify at least is there any short circuit or open circuit in the power supply lines. How would you check this? If you look at your PCB layout, let's say in the circuit diagram, you must be having supply, right? Let's say easiest thing is if you remember LCD. In LCD, pin number 1 is ground, pin number 2 is 5 volts. Similarly, pin number 15 is supply, pin number 16 is ground. So make sure this ground and this 5 volts, there should not be any short circuit. If you have time, then wherever ground pins are mentioned, check the continuity. Let's say for example, the entire track, right? If you see the where is the supply, right? So this is the thicker one is your ground. Now if I highlight this line, so on your entire PCB, wherever you see the highlighted, the red and blue highlighted one is called ground line. Similarly, where is your VCC? The next pin, pin number 2. So this is your 5 volts which is passing through the PCB. So if you have time, then you can also check the continuity wherever supply line is passing, wherever ground line is passing, continuity is there or not. And undoubtedly there should not be any short circuit between the ground and the VCC. So let's see physically how do you verify this. Okay. So take the multimeter, and if you see the ground pin and the VCC pin, there should not be any short circuit. If there is a short circuit, you can see for example ground I am checking wherever the ground pin is going, then it shows the continuity. You can listen the buzzer sound. But however, before soldering, make sure between VCC and ground, that is pin number 1 and 2 or 15 and 16, there should not be any short circuit. If there is a short circuit, do not do the soldering because it is a defected PCB. First you should remove the short circuit. Alright, so this is the bare minimum test. If you have time, check every track continuity, every pad from top to bottom. For example, if you have a pad from top to bottom, if it is conducting or not, because sometimes even the plated through hole, see, I'm just checking from the top to bottom. Okay, these pads. So that way also you can verify, right, these pads, the top to bottom continuity, the pads, before soldering, before mounting any of the components. Alright, so this is what I was trying to say, the bare minimum test. Once this is done, then let's start doing the soldering. If you want to do the soldering, alright, if you remember my video, I explained some basic techniques, right? The basic techniques is, first of all, when you hold the soldering gun, make sure the soldering gun temperature is properly set, roughly around 300 degrees, and then wherever you want to solder the pad, the soldering gun is approximately 45 degrees, soldering metal is again 45 degrees, and both the gun and the metal, solder metal, should be placed on the pad and should be heated on the copper pad itself. Okay, do not put the soldering metal on the gun tip and paste it here. We are not doing any pasting job here, we are actually soldering. Soldering means both the gun and the wire, soldering wire, should be placed on the copper pad and move this solder metal on the pad so that entire 360 degrees, all the sides, the metal should flow. Please understand, it should flow, it should be in the liquid state. So how to bring the liquid state? This soldering metal, once you solder it, remove the metal and this tip be there on the pad for at least a fraction of a second, so that this entire metal on all four sides is converted solid to liquid state and it will settle down. So that is a proper soldering. Otherwise it may lead to dry solder, or it may spill nearby pads, right? There are several possibilities. Or the shape looks like as if, right, some unwanted shapes and so on. Okay, so as you can see some tips in the slide also, right? Heat the part, add the solder, continue heating, let it will settle down, right? You can see it looks like properly settled down, the metal, and it should looks like uniform. Now some do's and don'ts. See, this is the proper shape, but this is means this metal is not melted, so that's why it is like a ball, round shape. That means some portion is liquid state, some portion is solid state. Only halfway soldered. This is cold soldered. That means actually this metal and this pad, there is no contact. You can visualize, right? You can understand. And this is partially melted, and this is short circuited between the two pads. So slightly heat the gun without metal and remove the metal between the joints, right? So that way you can do the cleaning also. These are the some. So let's cut this Burg strip 40 by 1 to the exact size of the microcontroller, which is 15 pins on one side and the 15 pins on the other side. So if you keep it exactly right, cut one extra pin, cut the 16th pin, not the 15th pin. And make it uniform. Rub the okay, good. Okay, it should looks like uniform. All right, so the microcontroller, which is the outer side, the 15 pin outer strip, outer Burg strip, put it on the component side. This is component side. Put it on the component side, this Burg strip. However, now do the soldering. As I told you, all SMD components we have soldered from the top side, but now we are soldering non-SMD components. Burg strip, hold with your finger, should not fall, and then again place the metal and the gun together and heat it. At least solder only one pin. Now you can see it should look straight and it should not fall. Okay, it's there, no problem. You can bend it slightly. Okay, now solder the rest of the components. So don't make a mistake. All components should be soldered on the top side where the silk screen is there, right, where the names are printed, and solder it from the bottom side. So place the gun and the metal together on the pad 45 degrees, melt it on the pad, heat the pad. Solder should looks like uniform. Solder should be there only on the pad, all four sides in the liquid state, so that heat it for a fraction of a second so that it should flow in the entire pad and it should not short the neighboring pads. Do not use the excess metal. All right, so one side you can see uniformity, similar, all the pad should looks like similar soldering. Okay, so we have soldered the first Burg strip, which is 15 pin. So take the second Burg strip, another 15 pin, put it on the component side and solder it from the bottom side in the same manner. First solder only one pad, keep it straight, put your finger on the Burg strip, keep the gun and metal together, solder only one pad and make sure it is straight, right, and then solder similarly the remaining pads by keeping the gun and metal together on the pad, heat the pad, put the metal, move the metal in such a way that all four sides the metal should flow and soldering should be done. neighboring pads should not be touched each other, or your metal should not spill on other pads. Even if it spills, don't worry, show it to me. Sometimes we can take care, it should not be an issue. But do not do desoldering without informing the instructor, otherwise you may permanently damage the pads or the tracks. Alright, so we have finished the Burg strip female both the sides, so that we can now mount the microcontroller, let's say ESP-32, which is having, as you can see, 15 pins on one side, 15 pins on the other side. Then there is a USB connector. That USB connector should come towards outside where the on-off switch is there. This side the USB connector should come. Make sure pin to pin is matching on both sides. If required, you can slightly bend the Burg strip without much force and press it. That's it. So that completes the at least a microcontroller mounted on the PCB which we have designed. And then we have soldered 4 LEDs, 4 resistors. Our earlier programs are meant for writing a program to blink the LEDs or to rotate the LEDs right to left, to verify various C syntax operators, conditional statements, loops, pointers, arrays, so many things we can test it on LEDs, including PWM techniques, right? We have discussed in the earlier videos. Similarly, in the previous session, I have discussed about inputs. So let us solder at least 3 more pins, so that in future, the next session, we can think of writing a program for reading a input. So let me solder 3 more pins. Exactly cut the 4th pin so that nothing will happen to the 3rd pin. 3rd pin should not be damaged. Alright, so I am mounting exactly as explained in my earlier session, where DHT11 is written. So only this DHT11 I am soldering. 3-pin Burg strip, so that I can write the program for inputs. Right? Initially we will short circuit the input pin either to VCC or ground, and eventually we will mount some sensors also in the same socket, because the advantage of this socket is one side there is a VCC, other side there is a ground, and the center pin is connected to microcontroller. So we will give either 3.3 volts or ground to that pin by short circuiting these 2 pins, and we will verify whether CPU is reading or not. So let's stop here the soldering part. Similarly, you can continue the rest of the components, but the purpose of stopping now, the reason is we'll write a program first for LEDs, whatever I thought in the previous sessions, and for the sensors, particularly switch or some digital sensors, we'll mount it on the socket where it matches, and we'll verify first the programs, and we'll slowly populate the rest of the components. Even if you have doubtful, again take the multimeter, check the continuity, keep your multimeter in continuity mode, and after soldering verify is there a short circuit between 5 volts and ground, or on your microcontroller 3.3 volts. You can see there is a pin called 3.3 volts. This pin and 3.3 volts and ground pin, there should not be any short circuited. Means where you have USB connector is there, boot is written, there 3.3 volts is there, that and ground there should not be shorted, or 3.3 volts and 5 volts there should not be any short circuit. So make sure these are the minimum precautions. 5 volts ground, no short circuit. 5 volts 3.3, no short circuit. 3.3 volts ground, no short circuits. That's all. Even if it is open circuit, no problem, because you are not going to damage the components. But if it is a short circuit, the power supply or some components you are going to damage. This precaution you should take. Now in the next session, we will continue the session about writing the programs, our earlier programs related to LEDs and the PWM and the switch sensors.